All right, so today we're going to continue on just comparing numbers. But the questions have become a little bit harder, right? Just because you haven't come across these kind of questions before. These are probably more similar to what you're going to see next year as in difficulty level, right? So here, the first question is, here, I'm giving you two numbers, here and here. Can you tell me the number or the fraction halfway between them? Exactly halfway between them. Because if I gave you something like 3 and say 5, what's number halfway between? 4. You can do that. That's not too bad, right? And if I give you 5 and 6, what's halfway between? 5.5, not too bad. But if I start asking you what fraction is in between,
Easy.
it becomes a little bit harder. It's still the same concept though. Okay? When we're comparing numbers, it's hard to compare fractions when they have different denominators. Once you make them the same denominator, all we're doing is comparing the top numbers. So to do this, we want to give our rationals a common denominator. Common denominator. All right? So remember, common just means same denominator, bottom number. Same bottom number. Right? So we look at this and we go,
20.
thank you. We have 4 and 5, our common denominator. Oops, I wanted a highlighter. Between 4 and 5 is 20. So over here, we need to multiply by 5 to turn that into a 20. And we need to multiply this side by 4. Remember to keep these things equivalent so we don't change the value of the fraction. We need to multiply the tops as well. Right? So we do that. The first fraction changes from 3 over 4 to 15 over 20. And the second fraction changes from 4 over 5 to 16 over 20. Okay? Now the bottom numbers are the same. All right? Becomes a little bit easier to compare. We have, comparing the tops, 15 and 16. What number is in between these two numbers? 15.5. So the number in between is 15.5 over 20. Okay. Now that is a valid number. Unfortunately, that is not a rational. Because the way a rational looks like, a fraction, you need to have a whole number over top of a whole number. Right? So, but this is the valid number. This is the number in between. So we just need to convert this to make it look like a fraction the way we want it. So easy way to get rid of a half is just to multiply it by 2. Right? So we're going to multiply the top and bottom by 2 and just write the equivalent fraction out. So it will be 31 over 40. That's the fraction halfway between those two things. Does that make sense? Sort of? Yeah. Okay. So another similar question here, but now this time, instead of giving a fraction, I've given you decimals. We could turn each one of these into fractions, just like we had over here, and do the same process. But I think this one's a little bit faster, because I'm betting you can just look at there and tell me the number that's in between. What's the number between negative 0.4 and negative 0.5? What's the number halfway between there?
4.5.
Yeah, negative 4.45. So, but the question asks us to write this as a rational, as a fraction. So we did this last day. How do we turn that fraction into, that decimal into a fraction? We need a numerator, we need a denominator. What's our numerator? Yeah, we take the number we see, we put it on top, then our denominator was a multiple of 10, 10, 100,000, 100,000. What would it be in this case? 100. We just counted how many decimal places there were. Right? So now that's the fraction in between. Now if the question asks you to do it in simplified mode, you can simplify this, right? You divide top and bottom by 5, or even a number maybe even bigger than that, right? but you've done the hard part. You found the fraction in between. The rest of it is just simplifying. Right? So not hard questions. The hardest part is just understanding what the question is asking and figuring out the process. Once you know what the process is, it's just straightforward calculations. Okay, now let's go to this one. We have this question. Okay? And there's more terminology that's going to trip you guys up. So we have the number -7/2 and the number 11 and 3. And I want you to give me all the integers in between these. So you can't even answer this question until you know what the word integers means. Right? Because you can't give me an integer if you don't know what an integer is. Who knows what an integer is? Arden?
A number without a decimal, right?
Yeah, like a whole number without a decimal.
Whole number.
Yeah, so integers are positive and negative counting numbers, right? So 0, 1, 2, 3, 4, 5, then -1, -2, -3, -4, and just kind of going like that. So we need to figure out what are all those numbers in between these. It's not asking us to work in fractions, so we don't need to work in fractions. It might be easier for us to work in decimals. So let's convert these into decimals. What is their decimal equivalent? So we can just find out what are the numbers in between. So the -7/2, you punch it through your calculator, what number do you get? You might be able to do that in your head, right? What's half of 7? 3.5. And this is a negative number, so it'll be -3.5. All right? And now 11/3 might be a little bit trickier to do in your head, but some of you guys might be able to do that. Right? Can anybody do 11/6 in their head? No? Miles, you got it?
3.6 repeating 7.
Yeah, 3.6 repeating. So you just go like this. So we need to find all the numbers in between. I find just putting these things on a number line makes it just so much easier to process. So I'm going to draw myself a number line here. On the far left is the -3.5. On the far right is the 3.6. And I just got to imagine all the numbers in between. So if I think of this as a number line, just to the right of -3.5, what integer would be sitting there? -3. That's the first integer we'd come across. Right? What's the next integer after -3? -2, right? And we just go up from there. -1, 0, 1, 2, 3. Until we hit this boundary. We can't go to 4, because then we'll be on the other side. So what are all the integers in between? These guys. Right? Not difficult, it's just understanding. And hopefully in a month from now, when you guys do the test, you remember that process, right? Okay. Okay, final question for today. We have a question very similar to the one we did at the beginning of these notes yesterday, right? I've got a list of fractions here and some decimals, and I want to put these on the number line. Last time I gave you the spots. This time you need to figure out the spots. Now this is where things get a little bit harder, right? Before you can place them on the number line, you need to figure out what the spacing is. Because now, once you get to grade 9, grade 10, not everything goes up by 1. In fact, the 1 is way over here, so these lines are definitely not worth 1 each. How much are they worth? 0.2, thank you. Each line is worth 0.2. And if you're not sure how to figure that out, all you do is you go for that 1, and you count how many lines there are. 1, 2, 3, 4, 5 lines to get to that 1. And you grab your calculator, you go, so that 1 is divided into 5 sections. So 1 divided by 5, because it's divided into 5 sections. So each section is worth 0.2. Right? That's just easily how you can figure out how much each line is worth. Okay? Now, if it's helpful for you, you can write these numbers in. Typically, we don't do that because it gets a little messy. And then we just do it every 100th one. But if you find that helpful for you, you can write all the numbers in there, right? Right? But it's important to note it's worth 0.2 each space. So now we need to put these on the number line. I'm just going to label these sort of like we did in the front. I'll call this one A, this one B, this one C, this one D, and this one E, and find their homes on the number line. Right? We just work our way from left to right. We have that negative 2.2, so that's going to be somewhere around the 2. Do I go left of the 2? Do I go right of the 2? Left. Do I go one whole line? Yeah. Each line was worth 0.2. So A is going to sit right here. Okay. Now B, 5 over 8. This number you should remember from the quiz. What is that decimal version?
625.
Yeah, 0.625. Okay. So now this is where I'm going to get a little more pickier than if you were in my grade 8 class. Right? 0.625 is somewhere between 0.6 and 0.8. Is it halfway? I want you to roughly put it in the right spot. Right? Halfway between 0.6 and 0.8, it would be 0.7. Right? So this 0.625 will be kind of closer to here. Right? It's kind of hard to place it accurately, but you can kind of break up this space to half, a little bit less than half, or a little bit more than half. So this dot is somewhere between this line and the halfway point, somewhere in there, right? That is a nice, accurate, roughly accurate location of it. It's definitely not over here, right? That's 0.7 something, right? So I want you to get in the habit of doing that, because as you get into science classes, right, nothing ever is going to line up now on a perfect grid mark. So you need to be able to estimate between two lines. Okay, C, negative 9 over 10. What is that as a decimal? You should go 9 out of 10, right? Negative 0.9, yeah. Negative 0.9, right? Okay, so I go here. I'm in the negative section. So how far do I go past 0? Where do I put it?
After the 0.8.
After the
halfway to 0.1.
Here's 0.8, right?
Halfway through 0.8.
Yeah, halfway between 0.8 and the negative 1. So this is negative 0.8 here. And 0.9, negative 0.9 will be halfway in between. So we'll be right there. Boom. So roughly, not close to that line, not close to 1. Run the middle point. Okay. Okay, D. We're at 0.3, negative 0.3, 333 continuing. Whereabouts would that be? Where would D be?
Halfway between 0.2, negative 0.2 and negative 0.4.
Yeah. Here's negative 0.2, here's negative 0.4, and negative 0.3333 somewhere in the middle. So yeah, that goes somewhere around here. Oops, forgot the negative sign. That'd be D. And finally, E. Where would 9 over 10 fall?
Halfway between 0.8 and 1.
Halfway between 0.8 and 1. So that would be right here, 9 over 10. Okay. So now the last part is just saying, hey, can you arrange these numbers in ascending order? We did that on the number line, but we just got to list it out. For A, that was negative 2.2, so we'll write that out. Negative 2.2, why aren't you disappearing? Oh, come on. Oh, there we go. Then we have C as our next one. So we go over to C, we find out what C was. C was the negative 9 over 10. Then we go over to D, find out what D was. D was the negative 0.3. Then I go over to B, find B. B was 5 over 8. I do that one. And I find E, which was 9 over 10. There we go. And that's it. Smallest to biggest. And you got about